Have you ever just stopped and wondered what kind of tech is humming away behind a massive financial app? An app that's got to handle millions of people and, billions of dollars? Well, today, that's exactly what we're going to do. We're going to peel back the curtain and design a stock trading platform, kind of like Robinhood, from the ground up. And let's start with a number just to set this stage. 20 million. That's how many active users we need to be thinking about every single day. So every single decision we make from here on out has to work and work flawlessly at that kind of insane scale. All right, so before we even think about writing a line of code or picking a database, we have to do the most important thing first. We have to define the rules of the game. We need to get super clear on the problem we're solving, what our limits are, and what exactly this thing needs to do. Okay, first things first, and this is a huge distinction. We're not building the New York Stock Exchange. We're building a brokerage. So think of it like this. Our system is the friendly face, the front door for our customers. It takes their orders and then passes them along to the big external exchanges that actually do the buying and selling. Now, this makes our job simpler in some ways, but it introduces a whole new set of fun challenges. So what are our users actually doing? Well, it mostly comes down to two kinds of orders. First, there's the market order. That's basically you saying, I want this stock right now. I don't care about the exact price. Just get it for me. Then you have the limit order, which is a bit more strategic. It's like saying, hey, buy me this stock, but only if the price hits this specific number. And our system, it has to handle both perfectly. When you boil it all down, the entire platform really only has two main jobs. Job number one, show people live up to the second stock prices. Job number two, let them create and cancel orders. That's it. Sounds almost too simple, right? Well, as you're about to see, the real devil is in the details, or what we call the non-functional requirements. And here they are. This is where the real engineering challenge kicks in. First, we need absolute rock-solid consistency. You can't just lose an order, ever. Second, it has to scale to those 20 million users we talked about. Third, it has to be fast. We're talking less than 200 millisecond latency for everything. And finally, we have to do all of this while keeping our usage of the external exchanges to a minimum, because let me tell you, those connections cost a ton of money. This right here, this is the puzzle we have to solve. Okay, we've got our ground rules. Now let's start sketching this thing out. We're going to start with the building blocks, the core data models, or what we call entities, and the API, which is kind of like the main entrance for every single user interaction. At the heart of this entire complex system, there are really only three main things. You've got the user, that's obvious. You have the symbol, which is just the ticker for a stock, like AAPL for Apple. And then you have the order, which is the magic piece that connects a specific user to a specific symbol with an instruction. These three things are the foundation of our entire database. And this is the front door I was talking about. This is our API. It maps directly to what our users need to do. Want to get the latest price for a stock? That's a GET request. Ready to buy? You post a new order. Change your mind? You delete it. Want to see your history? You guessed it, another GET request. This is the simple contract our app on your phone uses to talk to all the powerful machinery in the background. Okay, it's time to tackle our first really hard problem. We promised our users live prices. So how do we actually pull that off for millions of people at the exact same time without, the whole system just catching on fire?
Right, let's frame the problem. Picture a literal fire hose of price data coming in from the exchanges. It never stops. At the same time, you've got millions of users staring at their phones, all watching different stocks. How in the world do you get the right price update to the right person instantly without melting your servers or their phone batteries?
So we could do what's called polling. This is basically like having the app on your phone repeatedly ask our server, anything new? Anything new? How about now? It works, but it's wildly inefficient. A way better solution is something called server-sent events, or SSE. With SSE, the app opens just one connection and keeps it open, and our server just pushes updates down that pipe the microsecond they happen. It's a total game changer for speed and efficiency. Okay, so SSE is fantastic for getting data from our servers to the user's phone. But what about communication between our own servers? We're going to have hundreds of them. For that, we need an internal nervous system, something ridiculously fast. And that's where this beauty comes in, Redis Pub Sub. So let's just walk through this. It's actually pretty elegant. You open the app and start watching Apple stock. Your phone connects to one of our many servers, let's call it server A, and says, I want AAPL updates. Server A then turns around and tells Redis, hey, I'm interested in the AAPL channel. Now, when a new price for Apple comes in from the exchange, it gets published to that AAPL channel, and Redis, in a flash, broadcasts it to every server that's interested, including server A. Server A then immediately pushes it out to you. It's decoupled, it's clean, and it scales like a dream. All right, we've got our real-time data flowing. But now we have to face what is arguably the most critical part of the entire system. When a user hits that buy button, there is zero margin for error. We are dealing with people's money, and that means consistency is absolutely everything. And this is exactly why it matters so much. I mean, think about it. You're making a financial decision based on the information that's on your screen. If your list of open orders is wrong, or if an order you thought you placed just vanished into thin air, well, the consequences could be serious. You have to be able to trust the system completely. Now, on a good day, when the sun is shining and the birds are singing, creating an order looks pretty simple. Step 1, we write the order to our own database and we mark its status as pending. Step 2, we immediately send it off to the real exchange. Step 3, the exchange says, got it, and we update our database to say submitted. Finally, step 4, we tell the user, success. Easy, right? Well, what happens when it's not a good day? What if we successfully send the order to the exchange and then our server crashes? Just poof, it's gone. Before we could update our own database. Now we're in a terrible state. The user's order is live on the market, but our system still thinks it's just pending. That's a huge inconsistency, and it's a potential disaster.
And this is our safety net. This is how we protect ourselves. We build a completely separate process, a little background worker, you can think of it like a janitor. Its only job is to constantly scan our database, looking for any orders that have been stuck in that pending state for too long. When it finds one, it goes and asks the exchange, hey, what's the real story with this order? And then it fixes our records. This little job is our guarantee that no order ever gets lost in limbo.
Phew, okay. We've defined our goals, we've wrestled with our 2 toughest problems, and we found solutions. Now it's time to put all the pieces together on the board and look at the final complete system architecture. And here is the whole shebang. Up front, you've got an API gateway and load balancer acting as the bouncer and traffic cop. You've got our symbol service, which is the chatty component handling all those price updates with SSC and Redis. Then there's the order service. That's the real brains of the operation. Notice how the orders database is partitioned by user ID? That's a neat trick to make looking up someone's order history super fast. And of course, there's our heroic little order cleanup job, always working in the background to keep things consistent. Every single piece has its own specific job to do.
So when you look at all these moving parts, what you're really seeing is a resilient, distributed system. It's not one giant, monolithic application. It's a team of smaller, specialized services that all work together. This approach is amazing because it means if one little piece fails, it doesn't bring the whole house down. And it lets us scale up just the parts we need, all while making sure that consistency is the #1 priority. So we've designed a really robust system. But in the world of high-scale engineering, you're never really done. There's always another bottleneck waiting for you. So I'll leave you with this final thought to chew on. What happens when a meme stock goes absolutely viral? What happens when all 20 million of our users are trying to trade the exact same stock at the exact same second? How does our system handle that? Well, that's the next level of the challenge.